Hello and welcome to another Reigate Maths video. My name's Simon, and in this video we're going to be looking at the topic of algorithms on graphs from the Decision 1 unit of the Further Maths Edexcel specification. This video is focusing specifically on Kruskal's algorithm, which is a method to find a minimum spanning tree. Before we start looking at the algorithm, we're just going to go over a few key definitions that we have been over previously in videos before. The idea of a tree is very important for this topic because minimum spanning tree has that word in there. So a tree is a connected graph with no cycles. So any graph that satisfies that condition is called a tree. A spanning tree of a particular graph G is a tree that includes all vertices of G. And unsurprisingly, the minimum spanning tree, which often gets abbreviated to MS tree, is the spanning tree with the smallest weight. Or length. Now sometimes minimum spanning trees can also be known as minimum connectors. So if you see that phrasing, it just means the minimum spanning tree. Now for a small graph, these can be relatively simple to find just by looking, but for a larger graph or a larger network, you need a method for it. And in fact, there are two different methods in this specification that we're going to be looking at. This video is focusing on Kruskal's algorithm. Later videos are going to focus on Prim's algorithm. Kruskal's algorithm was first published in 1956 by American mathematician Joseph Kruskal, who did a lot of work in the field of graph theory, combinatorics, and a little bit of linguistics as well. Broadly, it works by sorting all of the network's arcs into ascending order and then adding them to the minimum spanning tree so that we don't fail with the definition of a tree. Formally, the algorithm is as follows. We start by sorting the edges into ascending order of weight, most likely using quicksort or bubble sort or some other sorting algorithm. In reality, in the exam, more likely you're going to be doing it just by eye. You then select the arc with the smallest weight and add that to the minimum spanning tree. You then consider the next arc of least weight. If it would form a cycle with any of the arcs that have already been selected, we reject it. If it does not form a cycle, you include it. If you have multiple arcs that are the same weight, you consider each in turn, and it might be that you get multiple minimum spanning trees, all of the same weight, depending on which ones you choose and when. You continue with step 3 until all vertices are connected, and as with all minimum spanning trees, you will end up with one fewer arc than the number of vertices. So if you have n vertices, you will have n minus 1 arcs in the minimum spanning tree. Now it's all well and good saying the algorithm like that, but much more useful is looking at an example. So this is the example we're going to work through. We've got a network there, and we're going to use Kruskal's algorithm to find the minimum spanning tree for this network. Now, as I've already said, there are two named algorithms that you will do for minimum spanning trees. In the question, you will be told which one to do. Listing the arcs in the order that you consider them is a bit of a misnomer or a poor instruction, just because we do that anyway as part of the algorithm, but then you might see that phrasing in a question. Part B, state the length of your minimum spanning tree, and Part C, draw it. Now, we can make sure that we can do parts B and C very quickly while doing part A. it's a really good idea with any minimum spanning tree question to draw them as you go, because A, it helps you check whether an arc would form a cycle, and B, quite typically you're going to have to draw it anyway as part of the question. So if you've already drawn it as you're going through the algorithm, that helps. Now, the first part of Kruskal's algorithm is sorting the edges into ascending order of weight. We're not going to do it by any sort of algorithm this time, we're just going to do it by inspection. So I listed the arcs there. What we're now going to do is we are going to select the arc of the smallest weight. Before we start doing that though, we're going to set up B and C together. So what I would advise doing is drawing out the shell of the network, so just drawing the vertices, and as we go through the algorithm, we're going to add arcs to this minimum spanning tree that we're going to draw here. And again, this is really useful to do because it's as you're going, because it's much harder to do it after the fact. So we select the arc with the smallest weight. That's DF, and we're going to add to tree. And we literally write it next to it. Okay, and then we're going to draw it here. And you can label them if you want to with the weights. I'm not going to. We then look at the next arc of least weight, which is BE. But you can see that's not going to form a cycle, so we add it to the tree. And we continue. CF, we can see adding this is not going to form a cycle, so we add it to the tree. Now we get to CD. If we add CD, we have a cycle here, which we don't want. So we reject CD. We don't want that. Okay. Now you can write reject next to it, you can bracket it, you could even strike through it, but I'd advise not crossing through it, just because if you cross using a thick pen, you might mar the working here and make it difficult for the examiner to see. So we've rejected CD because it formed a cycle. So let's keep going. DE, we can see adding that doesn't form a cycle. So we're going to add that. AD, we're going to add. And then GF. We can now see that if we include any of these remaining four arcs, AC, here, we get a loop, or we get a cycle. And the same thing with AB, EG, and BG. So we reject all of these. Okay, and we're done. Because we have considered every arc, we've connected every vertex. This is our minimum spanning tree. The length of the minimum spanning tree is just adding together the weights of the arcs that we included. Two plus 3 plus 4 plus 6 plus 6 plus 7 should give us 29. Now, here, with all of the ones that were 7s, we wrote them in this order. If we wrote them in a different order, we might get a different minimum spanning tree. We might get the same one. It would depend on the preceding arcs. But here, we might, if we wrote these down in a different order, we might get a different answer for our minimum spanning tree. That's fine. You can have multiple correct solutions. The key thing is, any correct answer will always have the same weight. And that's how you do Kruskal's algorithm. You see it's quite long, but it's relatively straightforward to do, and it gets a nice solution relatively quickly. Thank you for watching.